So anyway, let me maybe I'll get started with this thing. I okay. I almost got fired over this. I'll come out with it straight up, and I'm not totally out of the weeds, by the way. So in some sense, this was an incredibly expensive project. But I just set out to say, I just set out to figure out whether, and not just, so basically, when I did a little, and yeah, it's a little bit laughable. When I did a Google search for this, I couldn't find anything for like LLMs generating buildable Lego sets. I don't want images. Like images are worthless. I actually want a set that I can purchase. And so, so I sort of set out to do that. And then as a joke, I thought, you know what, maybe we can do a little side business or something. I even bought Brickle.ai or whatever. And then I got permission from Google to sort of, to do it as like a moonlighting thing. I don't know if we can make any money though. That's the problem. It's, I think the overhead is going to be small. Here's the question though, how would you even do this, right? So it turns out that the funny thing about LLMs is that they can learn anything that's kind of language-like. And that's not just language, but let's say that's things like DNA and protein and Go and music. And this finally happened, by the way. I used to joke about LLMs and dolphin language. Turns out just the other week or whatever, we finally got dolphins, like thank God. And then, by the way, I think when the aliens finally come, there's going to be LLM for aliens or whatever. It'll be fantastic. So we need a mechanism to describe Lego sets in a language-like way, and thank God this thing exists. So some beautiful sort of autists have created this thing called MDR, which is some kind of model description language, embedded in which are a bunch of these little LDRs, and it turns out that these things describe Lego sets. So this set in particular ends up describing this train, right? And so the beautiful thing is that essentially a bunch of people, and in particular, I guess maybe this guy, Robert Pechorek, have sort of, they've lovingly, and I don't know exactly how they do this, they've lovingly taken a set like this, and they've somehow piece for piece basically recreated this thing in one of these CAD, Lego CAD tools, and then kind of dumped the results. And then they've made these things available online. And so the beautiful thing is we have about 1,800 extant sets that have been sort of described like this. And the beautiful thing about this is this constitutes our training set, right? And 1,800 examples is kind of, it's probably kind of reasonable. And so the question is though, given some abstract description of a set, how are you actually going to train on it? And so the thing I came up with, and I don't know if this is the optimal solution, but what I did is so for every single set that I found, and I got about 1,800, I generated a kind of a rendered image, and then I asked the model to essentially describe this image, just kind of verbatim, avoid the L word. And then based on that, I just said, listen, can you come up with kind of 5 representative, sort of diverse queries that somebody might ask if they were trying to build this thing? And so what the training set ends up looking like in this case is essentially for every single query, this is our input, and then the output is that long sort of MPD file. And it turns out that this works reasonably well. So that means, though, of these kind of 1,800 sets that we have, we multiply it by 5. Does anybody have an intuition for how much it costs to train a model on 1,800 Lego sets? Just out of curiosity, with 5 queries per set. Anybody have like an intuition, maybe just even like order of magnitude? 2,000, not bad. It's about an order of magnitude off. $20,000. $20,000. So, and this is how I got in trouble this week. God. So anyway, and in some sense, I feel like this is a cautionary tale. For some reason, when I was a kid, I had this poster. It was called a demotivator, and on it, I think there was a dude who was getting eaten by some animal, and it said somehow your life exists as kind of an example for other people of like what not to do, something like that. Anyway, in this case, so I'm training this model. I happen to be using my personal cloud account, And as I'm training the model, I'm diligently looking at the billing. I'm like refreshing the billing page. Okay, 000. So there used to be a period of time when Gemini cost nothing to train. It was a sort of preview thing or whatever, right? And so I'm training this thing. My billing is saying 000, and then at 2 a.m., sort of like a shot through my heart, man. This, in some sense, I don't know if I'll ever forget this email. So I received an email which says, "We have successfully charged $20,000 to American Express." Like God, man. And the crazy thing is, like, up until that point, and still, even after I got that email, nothing showed up in my billing console. So if you're, just a word of warning, if you're training a Gemini model, you would go from 0 to $20,000 in 5 hours. It took 5 hours to train this thing. And so I remember, so I call it billing, and I got in touch with these people, and I said, "Listen, this is insane. You know, I don't know how I generated $20,000. Is there any way you can give me a refund?" Right. And basically this person was like, "You know what? I don't even see the 20,000. We have to wait 32 hours." So anyway, so for the past 36 or 48 hours now, I've been actually trying to get my money back. And I may have succeeded. It turns out, just because I happen to be inside Google, there may be this lifetime mulligan, where essentially they'll forgive me once, but never again. And but anyway, so anyway, basically in 2 weeks I'll let you know. Listen, if I have to shoulder this thing, it turns out that this was the most expensive meetup I've ever done in my life. It actually it pales in comparison to AGI House. So if we go to AGI House, that's 80,000. If this is 20, I guess that's, anyway, it's still fourth of an AGI House. Oh, yeah. Oh, okay. So, all right. So check this out. Check this out. All right. So I was talking to ChatGPT about this, right? And ChatGPT said, first of all, do not use the L word at all. Don't use it in code. Don't use it in your talk. And then ChatGPT said, also, don't wait for the L word lawyers to come to you. Go apply for a job or whatever, right? And I did. So this is a crazy thing. So I applied for a job at Lego this week. I had an interview this morning at 6 a.m. And the guy says, "Why the hell are you here? How did you come to this weird?" And I said, "Well, ChatGPT sent me. You know, it said, listen, it said basically ask for a job." And anyway, I got a follow-up interview, which is kind of weird. So anyway, I'll let you know in 2 weeks too, whether I'm here or if I'm in Denmark. God. Anyway, so we have some of the most expensive Lego sets, I think, to date. And here, actually have a couple of T-shirts. Yeah, that's basically. Yeah. So here's the horrible thing. This is possibly the horrible thing. I have $100 budget. Yeah, no, I have $100 budget. It blew through my budget. As a non-lawyer, though, I would think that this is a solid argument. I hope so, but here's the problem. I have to make that argument or whatever, and you know, they just may say, "Hey, come at me, bro." Like you know, but no, in principle, you're correct, right? You know, yeah. Anyway, you're right. So anyway, let's just see for this. Let's just see what $20,000 buys, okay? And here's the thing. I have a couple T-shirts. If anybody can name what the hell these things are, you get a T-shirt. And by the way, I feel like I was telling Justin, this is actually the most beautiful T-shirt we've done, I think, all year. Honestly, I wouldn't wear any of the other T-shirts. This is the only one I'd wear. I think it's colorful. There's some Legos in there. So let's play the game. What the hell is this? Okay. Oh man, and these are cut off on the bottom. Does anybody know what the hell this is? Okay, so that's funny that you say that. That's a good one. That's a good one. Okay, so here's a funny thing. All of the training data falls into 3 categories. There's cars, there's castles, and there's Star Wars. So basically, like, you know, that's all the model knows about. And oh shoot, let me see if I can make this smaller. Hold on. Let's see if
Airplane.
You know what it comes to.
It's one of the Star Wars.
Yeah.
Let's see if I can. There's no way to make this smaller. That's crazy. Let me just see if I can. It keeps getting bigger. That's crazy. 1 second. Okay, here we go. Okay, so let me just see if I can do this. Okay, so anyway, this is. I asked Gemini to make a self-portrait. right? This is self-ported. Here's the thing. Okay, this is self-ported at temperature equals 2. Okay, so here's the funny thing. I didn't even know temperature 2 exists. For me, my entire world is 0 to 1. And if you go to Vertex, if you go to AI Studio, there's fucking 2. Okay, so 2, when 2 is basically acid, right? So I think when you're basically on 2, this is self-ported LSD. Okay, this is which actually, and maybe if you're on acid, maybe this makes sense. But let's try this again with temperature 1. What's that?
What that means?
What's the mean? What?
It's something that you put in front of the river, so you get more graining. Thing.
Oh yeah, you mean the temperature, or you mean the? Oh, this thing or whatever. Oh yeah, that's funny. No, you're right. You're right. But anyway, so here's temperature 1, right? And the funny thing is, I don't have a pointer. So here's temperature 1. So at temperature 1, at least you're getting something like structures. And then if you squint, there's like a couple eyeballs and maybe a little mustache, and I think maybe some legs, some arms. What's that? Potato head. It's almost Gemini sort of lying on some operating table. This whole thing is a little bit creepy. There's some, but you can kind of squint. It looks like something. And then here's the funny thing. Here's temperature 0.5. And actually, I don't know why, temperature 0.5 is actually legit. It's sort of getting there or whatever, right? Like this is about how I picture these alien LLMs, like this sort of kind of these arm-like things. I don't know what the hell these eyeballs are. Like basically, when I look at this looks like an alien species that kind of hit Earth. This is just a PNG, so you can't rotate. But in the CAD software, you can see that there's little body parts kind of interspersed. It's it's getting there. So that's it. And then I already gave it away. What about this? I already gave it away. If you didn't catch it, does anybody? What's that? What's that? Oh, gun. It does look like a gun. So this is Gemini's version of ChatGPT. Huge brain, gun, a little bit scary. And again, you see eyeballs, and then I think there's a little bit of a mustache. This is something, but this is apparently how Gemini sees GPT in Lego. And here, by the way, this is a funny thing about these sets. Let me just see if I can go back to this one. It turns out that they're impossible to build, of course, right? So if you look at this, there's sort of a brick, and then this brick is occluded in the other brick. And so here's the funny thing. If you want to build this, you have to be incredibly skilled in the sense that you actually cut out a sort of brick-like piece in the brick and then kind of assemble it. And parts of the pieces may be in space. These ones have to be glued together. Actually building this, and so we may do maybe we'll do a follow-up to this. I don't know next time. One of the side effects of this Lego software is that it'll generate steps. And so one of the things I'd like to do if we do a follow-up either in a couple weeks or some other time, I'd like to just actually order one of these sets, build the set, bring it, and compare it to the original. But essentially, you have to be incredibly skilled because you have essentially pieces occluded in pieces. Okay, so anyway, we got GPT. You know what? This is actually one of my favorites, dude. This is one of my favorites. What's that? Yeah. It's a camera. It's a camera. I'll put it this way: it's significant that the camera is orange or whatever. Right? I don't know if anybody can guess who that is. What's that? What? Who said Donald Trump? Who said Donald? All right. So in particular, maybe I'll just hear, and maybe just in the back too, man. I think it was simultaneous. Sort of like the invention of calculus, man. You guys got it at the same time. It's not just Donald Trump. This is Donald Trump serving French fries at McDonald's, right? This is, but anyway, so I don't know if these are kind of other McDonald's workers. So one thing I'll say, and actually I didn't go into this, just the technicalities a little bit. So when you're training these data sets, the max output tokens you can do is 32,000. And so one of the things I did is I subsetted other Lego sets, and I took the ones under 32,000. Here's the problem. When at inference time, you can actually only do 8,000 tokens. And so what happens is I didn't have another 20. I was in the process of actually retraining the model with all the sets under 8,000, but I ran out of money. But the unfortunate side effect is that most of the sets are truncated. And so what you see is probably a truncated version of Trump at McDonald's. In some sense, I'd love to see the whole thing or whatever, right? But maybe just maybe just moving on a little bit. Can anybody squint and sort of make this one out? So it's a spaceship. Keep in mind that basically this model has been trained essentially on tractors and spaceships. And oh yeah, it's right. So I was trying to figure out CAD, right? So little whiskers, right, happening. I mean, creative use of these knights with kind of fire. I can kind of see a tail and a body. Again, this was a truncated build, and the kind of thing is, I'd love to see what this looks like at 32,000. But anyway, so some of these, I actually wanted to I got a little bit abstract with this one. And does anybody know what this might be? Anybody have a guess? What's that? Yeah. Somehow basically the language of all these models is tractor, just because it's training data. But this happens to be where Gemini lives, right? So this is Gemini's house, and again, truncated build or whatever. It looks a little bit like a not the Star Destroyer. What's that class of ship? Or anyway, a little bit sinister. And that's at temperature 1. At temperature 0.5, this is interesting. Is this the inside of a CPU? Is this sort of a neural model? That's where Gemini lives at temperature 0.5. Again, I'd love to see the whole build. And anybody have a guess on this one? Yeah, there is a little flower there. What's that? Yeah, it is a houseplant. This is Gemini's body at temperature equals, so somehow it's growing leaves. This is interesting. And then and this is Gemini's body at 0.5. So again, it's a truncated build. At 0.5, its world looks a little bit CPU-ish, and let's see about this one. Oh yeah, this is an interesting one. And again, it almost reminds me of like these early Dolly things or whatever, where you get 6 fingers, and like an alien species came down and sort of observed humans playing with Legos, went back to its home planet and said, "Hey, what the hell do Legos look like?" Anybody having a guess on this? Yes, unbelievable, dude. How is that possible? This is Gemini's mind at temperature. How the hell did you get that, bro? I don't know if you have like the Gemini transplant or whatever, or implant or whatever. That's amazing. That's at 1, and this is at 0.5. Like this is this is amazing to me. What the hell is this or whatever, right? It's sort of coming out of this body. There's sort of these memes. That is, what's that? Yeah, no, yeah, exactly. I mean, that must be what it is. And sometimes I see these like memes on 4chan or whatever with these dudes with huge brains. But what's that? Oh, that's my bill. Yeah, that's right. That's $20,000. Actually, right, that's a good one. That's a good. That's yeah. Oh yeah, that's right. That does look like a sheep. That's funny. Let's see. And then this is kind of the last one. If you can pull this out, dude, I gotta pack up, and I'll see you in what's that? God, that's so close. That's so close. That's actually it's not totally. Does anybody else have a guess? This is a universe. So essentially, I don't know if this is a Big Bang, and this is kind of the arrow of time. Anyway. And then lastly, I thought maybe just 1 second. I think, oh God, what's really interesting. So you can't see it here in the PNG, but in the actual file, oh yeah, this is really interesting to me. This is telescope and a scientist and something else, an observer and something else. And so somehow internally Gemini designated these things with roles. And then I think they come out as just abstract bricks, but that's fascinating, right? I don't, and by the way, you'd only ever see that in the source code, so to speak. But somehow Gemini, God, I totally forget. That's such a good point. Gemini assigns these really specific roles to these guys, and then to us, it sort of looks like these bricks. And maybe that's a little bit weird and alien. No, maybe that's how kids play. By the way, let's say you don't have any let's say you don't have any minifigures. Maybe to a kid that's the telescope, and I don't know. But yeah. Thanks for reminding me about that, Brent. Let me just see if I can. Let me just see if I can actually kind of show you what it looks like. Okay, how do we do this? Second. All right, let's see. This is Vertex AI Studio. Oh, I don't know if you want to see my $20,000. Let's see, do I have my $20,000 bill somewhere? Yeah, no, that's right. Yeah, no, no, you're absolutely right. You know, I don't know why I lost this. That's a shame. Give me 1 second here. Let me just see if I can recover this. Wait, this is it now. All right, Vertex AI Studio. Let me just see if I can do this real quick. Trading console. Okay. Okay, open chat. Okay, anyway, so somewhere I have a saved prompt, but let's just maybe, oh, it's not here for some reason. Oh, here we go. Okay, here's our $20,000 model. Let's go temp equals 0.5. And so just to show you how this works, 1 second, give me 1 second. Okay, yeah. So the way fine tuning works is that, let's say all of these thousands of examples, they have this kind of verbatim formula, which is I must sort of pick this arbitrarily. But when you train thousands of examples using this system instruction, it's essentially like a sentinel or a cue to the model that what follows should be a Lego set. Can anybody give me something? I don't something to build.
For that universe, we didn't
Yeah.
have a temperature of 0.5.
I think. Oh, what was the temperature 1 or was it 2? Oh, you know what? Yeah, you're right. You know, I wonder if I ran out of time. I could try 0.5 universe. Should we? Oh, okay, perfect. Perfect. Okay, lowercase or uppercase? I don't. Okay, let's ask it to build God. That's insane. All right. So anyway, this is extraordinarily. It's extraordinarily. Oh yes, nice. Okay, fantastic. There's certain things we can't build, dude.
Imagine you are making a movie and you got.
Yeah, maybe I'll try that. Let me see. Sometimes this, whatever that is non-deterministic. Okay. All right, maybe it's going. Okay, so let's see. Somewhere there's a stand, there's a horse, there's a rider. And the funny thing is, the model learned all these kind of fake authors. So in some sense, and then let's see. And then so, oh, interesting. Yeah, so basically when it's doing this, there's a bunch of bricks that it's, so this essentially 4162 is like a brick. And then these are different bricks. And then in theory, these steps here, so when you end up generating the instructions on how to build God, these will sort of be like, I guess these will kind of be discrete steps in the book. And by the way, the vision I had for this was, you know, you could build sort of sets for your kids for Christmas or something like that. I don't know if that's going to work out. They're so abstract. But, you know, maybe in that sense, it's just a difficult problem and we need some work. Another $20,000 actually. You know, here's a funny thing. I think they're like, Justin, you were saying through like AWS or through Google Cloud, they have these like little small business loans or whatever, or what credits or whatever, right? So maybe they'll give us 30K and then we can do another iteration.
I did talk to ChatGPT about this problem.
Yeah.
And it recommends there's a converter to translate an MPD file to
Yeah.
OBJ file.
Oh, interesting.
And
Interesting.
use this with 3D diffusion model.
Interesting.
Problem with using a transformer model,
Yeah.
don't do 3D.
Yeah, that's true. That's true. Right, right. Much like the, I don't know if you're around, but we did that one with, well, they don't even do 2D to a certain extent, right? Like, they do 1D. So I don't know if you're around for that Super Mario Brothers thing we did, but yeah, there it would generate all these physically impossible Super Mario Brothers levels, right? Okay, it's still going actually. I have a feeling this one's going to get truncated, which is sad. but at least we can kind of see what happens. But yeah, so anyway, if you drop 20K in a model, it turns out that performance-wise or whatever, I don't know if you need to drop 2 million to kind of get the still going. Wow. Just seems like, yeah, exactly. Oh, this is interesting. All of these are discrete steps. Wow. You know what? I think, and it'll truncate eventually at 8192 tokens. I don't know. Not that I can compile MPD in my head. I have a feeling because basically it looks like, I think this is X, Y, and Z. I have a feeling it's building one of those towers like we saw for Mind and Universe. Oh, truncated. Okay, here we go. All right, so give me a quick second. Give me a quick second. So, let's share this screen. Okay, so this may be a little tough to see. So this is his LeoCAD software, which does, it's a little bit interesting. I mean, it allows you in theory to sort of build your own models. And let's open up God and just see what happens. Yeah, okay, same thing. Anyway, let me just see if I can zoom in. No, that's what I was going to say, right? So that's actually, and I wish I could zoom into the bottom a little bit. Whoops. Let me just see if I can, it'd be nice to see the bottom of this thing a little bit. It's only letting me zoom into this. But yeah, I guess Mind and God and Universe are some, and by the way, this is at 0.5, at 1 and 2, I have no idea, but it seemed to be some structure followed by, and I don't know, maybe that's kind of a deep philosophical statement about the nature of Mind, God, and Universe. I don't know. Oh, yeah. Actually, you're right. And yeah. That's, yeah. Maybe, yeah. So that's entirely possible. So let's say we had a full 32,000 tokens for output. We could probably see the end of this. And maybe, by the way, for 32,000 tokens, maybe it's a huge, maybe that's effectively infinite or whatever for the model. Yeah, that's fascinating. But God, it's a really bizarre exercise in the sense that, and for me, this is actually all LLMs. Is Gemini making sort of a deep statement about God? Is this just stochastic? If we try to read into this, is it a silly exercise? I don't know. But I guess in some sense, it's humanity's job to make sense of these bizarre artifacts. This is a good one though. Maybe this goes in the like Bernd would say. Maybe this goes in the original. Hey Bernd, we'll run in our gallery. Actually, we'll run in our gallery. We'll do the first 10 LLM builds, and then maybe we can sell them for a couple million. I mean, somebody did the banana on the wall with duct tape for, was it 6 million? And somebody ate the banana, I guess. Surely we can get a couple $1,000 for the yeah. Oh, interesting. Yeah. Wow. ChatGPT. Yeah. You know what? If they invite me back for this on-site for Lego, I guess I'll go. Oh, San Francisco. Yeah. Oh, you're kidding. Wow. Oh, that's amazing. That's incredible. That's amazing. So, you know what? Actually, in terms of an A/B test, maybe if we do this again, we can actually train GPT and then just see what the difference is. But anyway, that's about all I have. I don't know if anybody has any questions or I don't know if you guys have anything. But yeah.
Well, yeah, I just wanted to ask, what was the data set that you used to fine tune this model?
Yeah, so the data set, maybe I can pull this up real quick. It actually literally is a $20,000 question. Yeah, let me just see here. So anyway, these people. So this is kind of amazing to me. So some people have lovingly crafted this thing called the OMR. So the OMR is basically, it's a repository of models. So like I said, so a lot of the training data, just see if I can, there used to be a way to like get all of these, no, that's parts and stuff. But anyway, so yeah, basically, and I think it's part of the reason why the training set is a little bit biased. So all the people that have like people have gone, they've purchased sets or whatever they've done, and then like they've lovingly recreated them in somehow like these 3D CAD things, and then they export it as an LDRAW file. I think the reason why the data set's a little bit biased is because whatever sort of godlike people have done this, they love castles, they love Star Wars, and they love trains. So in some sense, I think anyway, let's say the Elwood company had done something with it. Let's say they released their entire catalog at some point, then we'd have a really beautiful, diverse set. And but so in some sense, Gemini's doing the best it can with this kind of interesting, and there's a lot of these little guys, like these flagpoles, like in Gemini's self-portrait, you kind of saw some of these elements come up, which is interesting. Yeah.
Thank you.
Yeah. Anybody else? Go ahead.
Yeah, interesting concept and great presentation. You mentioned at one point it also shows you the steps how to build the actual physical models.
Yeah.
Do you have a demo or do you just like a slide of that something?
Well, so that's I don't know if you can see, that's this. Right. So basically this file is this Lego file. And then what's interesting, what's interesting though is that there's a lot of stuff here that actually this is fascinating. This is fascinating. Okay. So there's a lot of stuff here which doesn't emerge in the render. So it turns out there was kind of a bunch of crap at the bottom followed by this tall thing. It turns out that was a stand and a horse and a rider. So somehow God is riding a horse and there's this huge flag or whatever, the huge antenna or whatever it is. And so actually, looking at the source code might tell you a little bit more about what Gemini's thinking. Just, but then, this eventually basically becomes, this gets rendered as like that 3D kind of model.
And this comes from all the like a religion text and like a literature that depicts God as like a male riding a horse or something?
Well, maybe, but
where does this come from?
So I think it comes from the training set, right? So like I said, basically in the training set, there's three things. There's castles, trains, and Star Wars. And so based on what Gemini's given, it does its best to come up with God. But it turns out that its universe essentially, it's almost like you ask somebody what's God, and their entire universe, it's both like medieval and Star Wars. And
one of those three categories.
Well, but a mishmash of all of them actually, right? So eventually when you get the model, like it gets like, when like for that, so an example was that cat, right? So somebody said, oh yeah, that looks like a train, it looks like a tractor. There were tractor-ish elements in the cat and there were like castle-ish elements in the cat. So somehow, when it does these things, it comes up with these strange mishmashes, right? And so, like I was saying, like, let's say there was some future in which Lego, like, oh, damn, I did it. Let's say this Danish company, like, open source the entire catalog, then you could have a beautiful training set that does the whole gamut of whatever. But essentially, you're seeing God from the point of view of somebody who knows horses and, whatever. Did you have a question?
You just said mishmash, which triggered a thought. Does it have a way of applying certain weights to the categories that if I were to ask it to, I don't know, construct a room, would it derive more from the Star Wars set versus the tractor set? Versus...
And that's a great question. So when I was trying to figure out how to construct this training set, I had the exact same question. And And so there are a couple of problems. So when I download these sets are actually, they're relatively complex, and it turns out that they're a composite of many sort of small models. And my original idea actually was not to take this composite, but to take sort of each one of these constituent models and essentially describe them and then train the model on all these bits and pieces. But then I was going to include these composites and attempt to weight them sort of higher, right? And I just never got around to it. But part of the reason why I didn't do that is because, unfortunately, if you take a thing like this and if you decompose it into its parts, you'll see this thing at the top by itself and some wheels by itself. All of the constituent parts seemed kind of meaningless. And so, but I mean, in like the best of all possible worlds, somehow you have all these composite parts, or you have all these individual parts. You have the composites. You weight the composites higher, and then the LLM spontaneously figures out how to compose these little primitives into like bigger, more complex things. Like that would be sort of amazing. But yeah, if you wanted to weight it higher, in the prompt, you could literally just say, you know, create a Star Wars themed room or whatever, right? Yeah. And in that sense, you can do it ad hoc in the prompt. And then if you want to do it in the training data, either you just sort of include more Star Wars, or I don't know if actually Marvel. Yeah.
Story comes from Norse god Odin.
Oh yeah. Oh yeah, right. You're right. It could be Marvel. It could be Marvel indirectly in the sense that maybe Marvel came from medieval myth or whatever. But yeah, that's a good question. That's a great question though. Yeah. Yeah. So right, exactly. So it's just fine tune on top of was it Gemini 1.5 Pro, and like I said, it'd be interesting to just do the A/B experiment on different models. You know, maybe throw an Ollama, maybe a GPT, and just see what happens. And like you were saying, LDRAW itself is a relatively verbose format. And so I wonder if it's a case that you can compress it a little bit and you can make better use of this 8,000 token context window, you know.
Pictures and stuff scenes from this representation.
Yeah.
I mean, without the visual modeling.
Right.
It's never gonna make any sense. This is why I'm saying, if
Yeah.
you do this kind of thing, you be working with visual models.
Yeah. Exactly. That's exactly right. And so in fact, one of the follow-ups I was thinking about doing was actually just maybe using one of the vision models to do this. You're exactly right. Oh yeah, hit me up. Yeah.
Ricker.
In the Discord, ChatGPT gave me a Bricker, $65 app. You give it your Blender file, which you can get from OBJ, which you can get from your 3D stable diffusion or mesh diffusion, whichever.
Yeah.
And it will print and it will take your mesh and then make actual Lego models that fits the shape that you ask for. And of course, the shape just looks like whatever you ask for, just like all the beautiful diffusion models do.
Oh, that's interesting. So no, you know what, you're right. That's actually the best way to go. I was hoping that so when I trained the model, there was a, which was I had the model describe the visual and then sort of associate it with the file, and so indirectly there's some association with the visual through the description, but it's a sort of thing where when it goes to compose the files, maybe the composition is meaningless, and you need something like a spatial intuition to actually.
Yeah, I mean, because what the transformer is going to give you is frequently. Things that rhyme with the sequences, but that doesn't have anything to do with what it looks like, other than the part where you're repeating common tropes that are in this vicinity. Yeah, here's the sequence. Because like you say, a lot of these subsequences happened a bunch of times, and it saw those, and those are the ones that it remembers.
Exactly.
So the composites, there's no structure to the composites at all. It just sometimes it happens to spit out sequences that are found from these subparts. So the part that you were talking about, it needs to decompose. That part it does. It will find the repeated subsequences.
You're right. And so I guess the hope was that somehow when it decided to compose these subsequences, whatever came out was meaningful in some sense. But if it is, it's sort of almost by random, right? But maybe that, doesn't that describe how it deals with language too? I mean, so when we're looking at this representation of God, we see an antenna, we see this, and we see the Tower of Babel. But when it's dealing with quote unquote normal language, we also do the same thing, right? I mean, are we sort of like projecting meaning into what, this strange statistical process? But you're right. Yeah, you're right. I guess as a purely linguistic exercise, it can spit out something that's valid MPD or valid LDR, but without being grounded in like a spatial intuition for that sort of thing, then you're right. It's maybe it's meaningless.
Well, I mean,
Yeah.
I'm not an artistic person, so I don't know whether there's some poetry going on there or not. But for example, the Tower of Babel's in there because the stuff that it knows, that's a word, that's a term that is associated with God and a bunch of religious stuff, and so it picked out. Oh yes, it found so a model that talked about that was semantically related, and so it's not like, and it's got no idea what it looks like, right? It's like, okay, the model description was terminology that was related in this domain, and so it prefers stuff from that model over others.
But one of the things, one of the things I was thinking about, and I don't know if this would be interesting, is just some sort of iterative process where the model is generating MPD, let's say, and it's a feedback loop. You sort of give the model what this looks like. You render it maybe incrementally, and as it's going, give the model some feedback loop about what it's actually doing. And I wonder, in some sense, if that would result in anything interesting. And by the way, for this, I think for artifacts, even for cloud artifacts, I think there's some similar process where, you can generate, let's say some kind of React app, render it, send it back to the model, and have this kind of critique revised loop. But I wonder if that would yield anything interesting.
Well, that was actually my first business idea when I quit Google last year.
Yeah.
And I did an experiment. So the thing is where do you get as you see, there are trademark issues. And so where do you get the rich creative material to put the LLM to create something entertaining? So my first idea was to convert public domain literature to Roblox content.
Oh, interesting.
And so I did an experiment working through, so Winnie the Pooh went to public domain last year. So we took the first chapter of Winnie the Pooh, and it did the whole thing. It wrote scripts, it wrote character descriptions, it wrote scene descriptions, it wrote code for puzzles, built an entire play world with game stations and stuff.
That's amazing.
So, but the thing, and so the pictures and stuff work great. And of course, like I say, you can use Stable Diffusion. You could make brick models and stuff. The place where it showed what was the problem that we're still dealing with, which is it can't do math and logic. So, so I said, okay, design me this world. And so it was the 100-acre wood game. It's got game stations, which were the homes of the different characters. I picked the last one on the list, which was Kanga and Rue's house. And so, okay, what's happening here? Okay, Kanga has, it's Kanga's pouch puzzles, and Kanga's got like 5 or 6 puzzles in her pouch. You pick them out, solve them. I just picked the last one.
Yeah.
It was an Einstein puzzle, right? A logic thing. Rue has 4 friends and 4 activities and 4 times of day, 4 locations. And then here's your hints, and then it tells you, here's the steps you can follow to solve the puzzle to get to this answer.
Interesting.
And so, of course, we know what happens. So I say, okay, well, is this the correct solution? Oh, yes, of course. Thanks for catching. There is a mistake. Let me change it. Which I knew was going to happen. So I say, okay, don't try to solve it yourself. Write a Python program that computes the answer to the puzzle.
Interesting.
And it writes out a Python program that uses the constraint solver library, solves the problem, it computes a solution, runs the first time, computes a solution. And I think, oh my gosh, all right, we're going to the bank. But it is a stochastic process. So were we lucky? So I run it a second time. The second code is completely different and doesn't even compile. So out of 10 runs, it solved the puzzle twice out of 10 times, which is the 20% completion rate we get on asking LLMs to solve relatively simple logic problems.
That's interesting. That's interesting. So maybe that's great for some kind of critique revised loop. But that's really interesting. That's great. So listen, I think we're let's see, Justin, what do you think, man? We're at we got about 20 minutes left. Should we just do some just do some social. Unless anybody has anything, maybe we can just get some snacks and hang out a little bit. I guess we have the place for about 20 minutes, right? Yeah. But anyway, thanks everybody for coming. Yeah. And then I guess, are we doing every 2 weeks after this, Justin? Yeah. So I guess we offset a little bit for the holidays, and hopefully we'll get together in 2 weeks on the 20th, and then whatever that is. So hopefully we kind of sidestep, what's that? Yes, still let me know. Yeah, knock on. I don't have any wood. Oh, here we go. Knock on. There we go. Yeah.
Maybe you can make slam out of it, so this logo
Oh, yeah.
and mapping, creating the whole map of a round with groups of that.
Actually,
Maybe use that on this.
actually, that's not a bad idea. But okay, everybody, thanks so much.